Solubility. See, the solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent at specified temperature. It depends upon the nature of solute and solvent as well as temperature and pressure. Usually the solubility, here we are going to discuss solubility of a solid in a liquid and the solubility of a gas in a liquid. Okay. First we will see what is the solubility of a solid in a liquid. See here, the every solid does not dissolve in a given liquid. See, while there is the sodium chloride and sugar dissolves readily in water, naphthalene and anthracene does not. See here, on the other hand, there is naphthalene and anthracene dissolve readily in benzene, but does not in sodium chloride, and sugar do not, like this. See, that means the polar substance dissolves only the polar solvent. So polar substance, see, the polar substance means what is the sodium chloride. Sodium chloride dissolves only in water, does not dissolve in any organic solvent. Okay, because the organic solvent is a non-polar solvent. Non-polar solvent means there is organic solvent. See here, when solid solute is added to the solvent, some solute dissolves and its concentration increases the solution. So this process is called a dissolution. Some solute particles in solution collide with solid solute, the particle gets separated out of the solution. So this process also called the crystallization process. See, a stage reached when the two processes occur at the same rate. So under such condition, the number of solute particles going into the solution will be equal to the solute particles separating out the state of called dynamic equilibrium is reached. That is, solute plus solvent, they reach the dynamic equilibrium and gives the solution. Okay. So at this stage, the concentration of the solution in will remains constant under the given condition, that is temperature, pressure, like this. So similarly, the process is followed when gases are dissolved in a liquid solvent. Such solution in which no more solute can be dissolved at the same temperature, that is under pressure, is called a saturated solution. Usually solution type, that is solid, solubility of solid in a liquid solution, usually saturated and the unsaturated solution. What is saturated? What is unsaturated? See, no more solute can be dissolved at the same temperature. That's the given solvent, that is called saturated solution. Unsaturated solution means that can be dissolved. There is solute can be add, excess of solute can be add, that is up to that saturated solution reaches, means that before that is called unsaturated solution. Usually solutions are two types, saturated solution and unsaturated solution. See here, the effect of temperature and the effect of pressure in a solubility of a solid in a liquid. First we will discuss the effect of temperature. So effect of T, that is temperature. The solubility of a solid in a liquid is significantly affected by temperature changes. That is, the equilibrium usually, see, this solid plus solvent give solution. That is being a dynamic equilibrium. They must follow the Le Chatelier principle. In general, that is the saturated solution, the dissolution process is endothermic. That means the delta H, the enthalpy of a solution is greater than 0. So the solubility should increase with the temperature if this will be a endothermic, and that is endothermic process, and that's solubility of a enthalpy is decrease in 0, delta H less than 0. This reaction is called exothermic. So exothermic process. Here these trends are also observed experimentally. Then effect of pressure. So effect of pressure. So what is the effect of pressure? The pressure does not have any significant effect on solubility of a solid in a liquid because it cannot be compressed. Okay, only if a gaseous molecules mean we can compress. So that in a solubility of a solid in a liquid, the effect of pressure does not have any significant. Okay. The next is solubility of a gas in a liquid. Here the solubility of a solid in a liquid, as many gases dissolve in water. Oxygen dissolves only to a small extent in water. It is the dissolved oxygen which sustains all aquatic life. See, on the other hand, the HCl gas, that is hydrogen chloride gas, is highly soluble in water. Thus, the solubility of a gas in a liquid is greatly affected by pressure and temperature. So, the solubility of a gas increases with increasing of pressure. For the solution of gases in a solvent, consider the system, that is the here this is called the effect of pressure on the solubility of a gas, that is the concentration of a dissolved gas in the proportional to the pressure on the gas above the solution. See, this is the two layer line. First, this one is the lower part, the lower part of the solution, and the upper part is the gaseous system at pressure P and the temperature T. Okay, assume this system to be a state of dynamic equilibrium, that is under these conditions rate of gaseous particles entering and leaving the solution phase in the same. Look this in the same. Now increase the pressure. Increase the pressure over the solution phase by compressing the gas to smaller volume. Look at this diagram. So this is the piston. I am compressing this. So what happened? This will increase the number of gaseous particle per unit volume over the solution. Compared to here, this is like this. So over the solution, and so also the rate at which the gaseous particles are striking the surface of the solution to enter it. So the solubility of a gas will increase until a new equilibrium is reached, resulting in an increase in the pressure of a gas above the solution, and thus the solubility also increases. Mainly, Henry was the first to give the quantitative relation between the pressure and the solubility of a gas in a solvent, which is called Henry's law. See, the Henry's law, mainly the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. Okay, that is the Henry's law statement. Dalton, the contemporary of Henry, also conclude independently that the solubility of a gas in a liquid solution is function of the partial pressure of the gas. So if we use that, the mole fraction of gas in the solution, a measure of solubility, that is its solubility, that it can be said that the mole fraction of a gas in the solution is proportional to the partial pressure of a gas over the solution. See, remaining, the Henry's law commonly stated that the partial pressure of a gas in vapor phase is proportional to the mole fraction of the gas in the solution. Simply, we can write it that as P is equal to KH into X. This is here, the KH is the Henry's law constant. Here if we draw the graph between the partial pressure of gas versus mole fraction of the gas solution. Here the experimental result of partial pressure of HCl gas versus mole fraction of HCl in cyclohexane. Here this gives a what? The straight the plot is you will get a straight line, that is the plot. So the different gases have the different kH, that is Henry's law constant, different constant value, that the same temperature. So this suggests that the Henry's law constant is a function of the nature of the gas, nature of a gas. So it obvious this equation that higher the value of kH at the given pressure, the lower the solubility of a gas in a liquid. See, that is, you can see that higher the pressure, suppose that the kH values are both, that is like nitrogen and oxygen. The nitrogen and oxygen is increase the temperature, indicating that solubility of a gas is increases. Okay, that is increase with decrease of temperature. That you can seen in that table 2.2. Some experimental results are given in that textbook. You can see that some temperature, that is 293 Kelvin helium gas, that is some what is the pressure, what are the type of gases are used, you can see that. Okay, then Henry's law finds several applications in industry and explains some biological phenomenon that is we can list it here. See, the solubility of a gas is increased with decreased temperature. That is, the aquatic species, you know that the aquatic species are more comfortable in cold water rather than in warm water. Why? The reason is the dissolved oxygens are more in cold water. Okay. Now we will see the applications of Henry's law. That is also one of the applications. See here now the applications of Henry's law, mainly where it is applied. The Henry's law where it is applied. The soft drinks, scuba divers and climber, high altitude climbers. First, the solubility, the soft drinks, in soft drinks usually they increase the solubility of the carbon dioxide in soft drinks and soda water. So the bottle is sealed under high pressure. Okay. Then the scuba diver must cope with the high concentration of dissolved gas while breathing air at high pressure underwater. Okay. So they increase the pressure, increase the solubility of the atmospheric gases in blood. So when the divers come towards surface, the pressure gradually decreases. This releases the dissolved gas and leads to the formation of the bubbles of nitrogen in the blood. So this blocks capillaries and creates a medical condition is called bends, which are painful and dangerous to the life. So to avoid the bend as well as the toxic effect in the high concentration of nitrogen in the blood, the tank used to do scuba diver filled with air dilute with helium. That is, the helium, the percentage is 11.7% of helium and the 56.2% of nitrogen and 32% is 32.1% is oxygen. So scuba diver using this proportion gases. Okay. Then the climbers, that is the high altitude, the partial pressure of oxygen is less than that at ground level. So this lead to low concentration of oxygen in the blood and tissues of people living at the high altitudes are climbers. Okay. Low blood oxygen causes the climber to become weak and unable to think clearly. The symptoms is called anoxia. Okay. Then effect of temperature. The solubility of a gas in a liquids decrease with rise in temperature. So when dissolved, the gas molecules are present in the liquid phase and the process of dissolution can be considered similar to the condensation and heat is evolved in the process. Okay, we have learned already the that is, dissolution process involves dynamic equilibrium and thus must follow the Le-Chatelier principles. Okay, that's mean the dissolution and exothermic process, the solubility should decrease with increase in temperature. Okay, student. Next class we will discuss the vapor pressure of a liquid solution.